Hi viewers, welcome to Gunji Ashok Java interview coaching. In this video, we will discuss about difference between compiler, interpreter, and JIT. Okay, we will discuss in this video difference between compiler, interpreter, and JIT. Okay, compiler. Coming to compiler converts .java to bytecode. .java means compiler converts Unicode to bytecode. Okay, I will explain these points. Later I will explain everything with the diagram. Okay, you will get this information in Google also, but I will give full clarity about compiler, interpreter and JIT. Okay, JIT means just in time. Okay, compiler converts Unicode to bytecode and converts total program at a time. Converts dot Unicode to bytecode. Already this point is already done. It is available in JDK. It is fast compared to interpreter. It generates a file for bytecode. I hope you understand. Compiler converts Unicode to bytecode, converts total program at a time. It is available in JDK. It is fast compared to interpreter because of it is compilation whole program converts at a time. That's why it is fast compared to interpreter. It is generate a file for bytecode. Okay, this is about compiler. Next, interpreter. It is available in JRE. JRE means Java Virtual Machine. It is available in JVM. Interpreter. It is available in JVM, Java Virtual Machine. It converts bytecode to bitcode. Bytecode means .class file. .class file it will generate to bitcode. It is available in JVM, Java Virtual Machine. It is converts line by line execution. It is slow compared to JIT, and it is slow compared to compiler. So it is slow compared to compiler, and it is slow compared to JIT. It is not generated file for bitcode. Interpreter not generated file for bitcode. It converts line by line execution. Okay, compiler converts total program at a time. Interpreter converts line by line execution. JIT means it is available in JRE. It is available in JVM, Java Virtual Machine. Okay, here it is JVM. In JVM, interpreter and JIT is available. I will tell you detail. It is available in JVM. It converts bytecode to bitcode. It converts line by line execution. It is fast. It is fast compared to interpreter. It is not generated file for bitcode. It is similar to interpreter, but it is slow. It is fast. That is main difference between interpreter and JIT. But here many differences are there compared to compiler and interpreter. I will explain everything with the diagram. If you come into this diagram, here in C language demo.c, see if I like that we are writing. Unicode means universal code. Universal code means we are writing C language code in English letters. That is, we can call it as a universal code. Okay, this code operating system did not understand. That's why understand Windows operating system understanding format we should convert, and that code Windows understanding format code we don't know, and what we know Windows did not understand. What Windows operating system understand, that code we don't know. For converting Unicode to bitcode, one software is required. That software we can call it as a compiler. Okay, here what we know, Windows operating system doesn't know. What Windows operating system knows, that code we don't know. That's why for us and operating system understanding format, one software is required. That software we can call it as a compiler. It converts Unicode to bitcode. It converts Unicode to machine understanding format. It will convert. That code we can call it as a bitcode. For converting Unicode to bitcode, one software is required. That software we can call it as a compiler. Okay, suppose C language platform dependent or independent. C language platform dependent. If we copy in pen drive, if I copy this demo.exe file, if I run in another operating system, it will not run because of what compiler did here. Windows operating system understanding code it will generated. Okay, what compiler did here, Windows operating system understanding code it will generated. That's why in another operating system it will not run because of what compiler did here, Windows operating system understanding format it will generate the code. That's why in another operating system this .exe file will not run. That's why we can call it as a C language platform dependent. With this reason we can call it as a platform dependent. In which operating system we are running, those operating system only, in which operating system we are compiling, in same operating system only we can running is the possible. In another operating system it is not possible to running. With that reason we can call it as a C language is platform dependent. Coming to Java, here Unicode. Unicode means what we know, like we are writing Java code in ABC like English letters. That is we know. But what is an operating system understanding code bitcode? Operating understanding code bitcode. What we know Unicode. Suppose here Java file we are writing in universal like Unicode. That code in Java we are compiling. After compilation, what will be happening? Demo.class file will be generated. Demo.class file we can call it as bytecode. Here in C language, Unicode convert to operating understanding format, bitcode will be generated. But here bytecode will be generated. Here for conversion Unicode to bytecode conversion purpose one software is required. That software we can call it as a compiler. What compiler did here? It converts Unicode to bytecode. Okay, Unicode to bytecode here again, but operating system doesn't know bytecode. We also don't know about bytecode, but who knows this about this bytecode? JVM will understand about this bytecode. JVM understand format, it will compiler. What compiler did here? JVM understanding format bytecode it will generated here. Not only here, how many JVMs are there here? Many JVMs are there. For every operating system one JVM is there. Windows purpose one JVM is there. Linux purpose one more JVM is there. And Solaris purpose one more JVM is there. And macOS purpose also separate JVM is there. For every operating system separate JVM is there. Here bytecode we don't know, and Windows also don't know about this bytecode. But this bytecode no JVM knows very well. For that purpose, compiler generate bytecode JVM understanding format. It will generate bytecode. In JVM, interpreter also available. What interpreter will do? It will convert bytecode to bitcode. Inside JVM, interpreter is there. What interpreter will do? interpreter will do the bytecode to Windows understandable code. It will generated like bitcode. It will generated bytecode to it will convert to bitcode. Windows operating system understandable bitcode it will be generated by interpreter available in JVM. Suppose here difference between compiler and interpreter. Compiler total program compile at a time. Here interpreter line by line execution will be done. What is compiler generated a file for compiler generated a file, but here interpreter will not generate a file. Suppose here interpreter also will generated a file. That file you will copy in pen drive, will run in another operating system. Then what will you say? Here Windows understanding format it will be generated, but if you try if interpreter generate a file, you will copy the file in pen drive. You will run that file in another operating system and with the help of Linux JVM you are trying to running, but it will not running. Then what you will you say? Java is platform dependent, like you say. For that reason they will here interpreter will not generate a file for bitcode. Here bitcode we will see, but here bitcode we will not see. That is stored in RAM, temporarily stored in RAM. After compilation of we will get output. After getting the output, that will be vanished. Here bitcode we will not see. Here bitcode we will see. Bitcode, that interpreter will not generate a file for bitcode. If they give the chance to generate a file, what we will do? That file we will copy. We will try in another operating system. Then what you will say? Java is platform dependent, we will say. For that reason only they did not give this chance to generate a file. With that reason only, suppose here why they introduced interpreter will not generate a file. If suppose here also compiler is there. Compiler what will be do? Compiler whole program at a time will be executed, and file it will generate a file. With that file you will copy, you will test in another operating system. Like that internally will be happening here. Here also separate Linux Linux operating system also separate JVM is there. Here also in JVM also separate interpreter is there. What is interpreter will do here? It will generate bytecode to bitcode. Here interpreter interpreter also Linux operating system understandable bitcode will be generated. Here also interpreter what it will do? Solaris OS understandable bitcode it will be generated, and Mac OS also JVM will be available, and JVM also interpreter will be available. What interpreter will do? Mac OS operating system understanding bitcode will be generated. Like that it will be work internally. And difference between interpreter and JIT. Here total compiler total program will be executed at a time. Here line by line execution will be done. For fastly quickly we get for getting response quickly purpose, they introduced JIT purpose. Here interpreter also there and JIT also there. Some code will be executed by interpreter and some code will be executed by JIT. With that reason we can get the response quickly. Okay, that is the difference between compiler and interpreter and JIT. Here C language is platform dependent, and here Java is platform independent, but here JVM is platform dependent. Okay, here Java program is platform dependent, but JVM is platform dependent. With that reason only, suppose if you go to the Google, Java SC download. If you for every operating system software is there, like this is Linux, this is Mac OS purpose, this is Solaris purpose, this is Windows purpose, maybe Linux purpose also separate. Many types of, for every operating system separate software is there. With that reason only, for every operating system separate software is there. With that reason only, with this reason only, for every operating system JVM is dependent. With that reason only, for downloading Java software, for every OS separate software is there. Why? With that reason only. Here JVM is platform dependent, Java is platform independent. JVM is platform dependent and Java is platform independent. Like this internal work. Here Unicode, Unicode to conversion done by Unicode to bytecode with the help of compiler. Here two times conversion is done. Here two times conversion will be happening. One is compiler, it will convert Unicode to bytecode, and bytecode to bitcode conversion will be happening. Here interpreter. Here only one time only conversion is happening. Here two times conversion is happening. Unicode to bytecode one conversion with the compiler, and convert bytecode to bitcode with the help of interpreter. Like this works internally. Because of like this working internally, because of this reason only, platform independent, Java is platform independent. If you suppose bytecode you are copying, you are trying in another operating system, but here another operating system JVM is available. In JVM interpreter is available. Again what interpreter what will be doing here? Linux OS understandable bitcode will be generated. That's why here also any operating system will be running successfully. Okay, I hope you got the clarity difference between compiler and interpreter and JIT. JIT means just in time. I hope you got the clarity. Compiler means it converts whole program at a time, like Unicode to bytecode. Converts total program at a time. It is available in JDK. Like interpreter, it is available in JVM. It converts line by line execution. It converts bytecode to bitcode. Okay, I hope you got the clarity. If you have any doubts, please do comment in this video. I will answer you. Bye. Thanks for watching this video.